This is NBHM 2020 PhD solution. So evaluate the surface integral of the vector field on the surface given like this. ठीक है, तो ये निकालना है. So an integral which evaluated on a surface is called a surface integral. The surface integral का formula basic है f dot dA equal to f of dA, where s in dA ये जो है is also called the flux of f across the surface S, and this is the unit vector at the point P on the surface S in the direction of the outward drawn normal of the surface. Okay, so the projection of dA on xy plane is given by dA is so the unit vector in direction of normal to the surface is given by so f of n is this thing. So now figuratively we can write this formula in a newer way. Real f in dA. Okay, so the projection of S over y and x plane is dn, dx dz n of I. So S of f n at dA is dy dz n hat of I. So projection of S over xz plane dx dz n and j. So now theoretically we can utilize this thing. S1 n minus k hat z equal to 0, dA equal to dx dy. F of S1, this is f n hat dA. So this will be S1 minus e to the power x dA, double integration minus of e to the power x dx dy. This is the part given. On S2 a hat dA, double integration e to the power x dx dy, and on S3 it will be x equal to 5 cos theta, y equal to 5 sin theta, surface 3 f of n dA, S3 of 5. This if you calculate double integration, so 0 to 2, 0 to pi by 2, 5 cos theta e to the power 5 sin theta d theta dz. So let 5 sin theta equal to u, so this is du. So double integration e to the power u du dz this will be, and this will give you minus of 0 to 2 e to the power 5 minus 1 dz. So minus 2 e to the power 5 minus 1. So the surface integral is given by this. So the final value is minus 2 into e to the power 5 minus 1. So the absolute value of the surface integral, to take a modular, so it is 2 into e to the power 5 minus 1. This is the answer.